Okay, so on the bench today we have another K7000, and this time it's blowing the fuse. And this was sent to me by a friend who had this in one of his cabinets for the last 5 years with no problems, and all of a sudden it started blowing fuses. So I said, sure, I can take a look. So we're going to try and figure out what's causing it. And I figured it'd be a good example and a good time to show what could be wrong with a K7000 that's blowing fuses, or why it would happen. So the most common cause would be if someone hooks one of these up to a machine without an isolation transformer. When that happens, it can blow any of these diodes in the bridge rectifier circuit part of the power side. R103 can open up, it can blow the diodes in the power circuit, it can take out your voltage regulator, it can take out your HOT, it can take out some of the diodes here on the side by the flyback. I believe it's D13 and D14, those can go bad. So all that kind of stuff. So what we'll do is I'll go through every single component. Let's say you've got a 7000 that's blowing fuses. You don't know where to start. Well, let's go through every component that would normally cause that to happen. And we'll test everything, and when we get to our culprit, obviously we'll replace it and fix it, but I want to go ahead and show what everything should read and how you should go about testing this completely and thoroughly when you've got a fuse that's blowing. So let's go ahead and test our fuse just to show you that it's not copacetic. And you can see here that this is shorted. If we touch our fuse, open. If we take the fuse out of this circuit here, and it's not only is it, well, I can keep it under the light here, sorry, but you can see the burn mark, and it's toast, and there's pieces floating around in there. And I actually have a circuit breaker that I'm going to hook up to this instead of a fuse when we test it, so I don't blow through fuses. And there you go, it's open. So yep, yes indeedy, the fuse is bad. So we'll start with the normal suspects. Let's go to the HOT. And the HOT is, we'll go to our diode checker setting. And let's zoom in here a bit. Okay, so the HOT are these three pads here in this triangle. 1, 2, 3. We put our negative lead on the middle one, and you go to either end, and it should be 0.450 around there on each end here. So we go here, 0.442, that's good. We'll go to here, 0.442, that's good. That's how you check the HOT. So HOT is not the problem, or one of the problems. Then you have, we'll start up here in the right hand corner. R103, this ceramic resistor here, this should be about 2.7 ohms or 3 ohms. And if we go back to our ohm setting, and you can test this by simply going to the top lead here and then touching the inner lead. You can see there is the inner lead right here. And we'll touch that. That should be 2.9 ohms. Oh, get a better shot here. I'm touching the frame. There we go, 2.8. So R103 is good. That's all of these items I'm going to test here are items that you want to test, because any of them could cause your fuse to blow. So we'll start obviously with the HOT and R103. So all of these components are all going to be issues that you want to test with the blowing fuse. So R103 is good. Now we've got our diodes in our bridge rectifier circuit, which is just actually these four, but there's D24 and D23 as well. So you always want to check, obviously, with your diode setting, and the negative lead always goes on the side with the stripe, and the positive always goes on the side without the stripes. So let's do that. They should all be about 0.5 something. So let's just zoom out a bit. It's not out. There we go. All right, so D19. That's good, 0.5. D20. That's good. D21. Good. D22. Good. D24. And D23. Alright, so all of our diodes are good. Next we'll test, what is this one, R104, to make sure it's good. Should be 15 ohms, give or take. So we'll test this one, 15.2. Alright, and we'll test R101, should be about 6.8, but usually it's about 5. Usually it's about 5 k ohm in circuit, even though it says 6.8. Sometimes you can get them to read 6.8. It depends on the other components on the chassis, but I'm going to guess around 0.5. Or I'm sorry, not 0.5, 5 k ohm, give or take, I'll bet. Yeah, 4.4. So I mean, it's rated at 6.8, but with the real way to test these resistors is out of circuit. So if it's reading 4.4 in circuit, I'll let that slide. It's a bit low, but I'll let it slide. So it should be somewhere usually around 5, or if you can get 6.8, then that's pretty good. But and then we have R97, which I believe should be, I think, 290 ohms, give or take, if memory serves. But let's see here. Sometimes this gets pretty charged, so I go to the base of the leads here. 266, that's not too bad. So at least it's good. You're looking to make sure none of these resistors are open. Resistors don't short. They either read way out of tolerance or they read open. So as long as they don't read open and they read somewhat close to their rating, a lot of them have, a 2% tolerance or 5% tolerance, but we're not checking them out of circuit, so I'm not too worried about it. So at least those are somewhat good. I say those are good. And then we have which one is this? 89. We'll test R89 as this ceramic resistor here. Should be 3.9K. So let's test that one. And it is, if I can get on the lead there, 3.8. So close enough, that's good. So all that's okay. We already did our HOT. And now I guess we will do our D18. Way down in here, there is a diode across the yoke connection. It's right here in front of C38. It's hard to see. If I can zoom in here, there we go. D18 is this guy right in here, right there. That's a diode that can go bad quite often. You want to make sure that diode is good, and the negative side is facing this way, and the positive is this way. So if we zoom back out here, go back to our diode setting. And if we do our negative lead towards the inside and positive towards the outside, let's get in there. Can't see the bar or anything here. There we go. All right. So there you see 0.4939, so that's good. So our D18 is okay. That's an important thing that people often overlook. Well, I do notice here that the centering pin is missing completely. You can see right through the board. Or maybe you can. I can. There you go. You can see right through the board on the centering pin is completely missing. Not that it's an issue, but looks like it's gone. That's just a pad that wasn't soldered. So, okay, let's do our D12 and D13. I'm sorry, D13, D14. Those are the ones that are over here by the flyback. And on D14, the negative side is here and positive. And these are attached to the flyback windings, give or take. So even though it reads 0.226, it's a low setting for a diode, but because these are power diodes, bigger power diodes, that's not an unusual reading. So if we go to D14, which is, flip the leads around here, it's the other way. See, and that one reads 0.5. That's more of a normal reading you'd expect. So I'm not really too worried about this. I think, like on the 7400, 500, 5000, 2000, on those series of chassis, most of these power diodes read about 0.3 something, and that's good. So if this one's reading 0.22, I'm not too worried about that. At least it's not shorted. So we'll call it good. I'm confident that's okay. All right. Really, all that's left is our critical safety cap, which actually on some chassis, some 7000s have 2 caps here. If you look in there, you can see 2 of these blue poly caps in the C36 location. That's your critical safety cap. If those are gone, that'll definitely go out the fuse. So some of these have a single cap with 4 legs. Some have 2 individual caps. So, but it's these four legs here. 1, 2, 3, 4. These two on this side, these two on this side are your C36. And you'll want to leave your meter on diode checker still. And you want to go catty corner here. It doesn't matter if you go this way. You should read like a diode. I believe this way should read the same thing. Yeah, it reads slightly different, but you want to read. You want to go diagonal, and it should read like a diode. So that's good. We go the other way. That's good. So our critical safety cap is good. Of course, this should read shorted, and this should read shorted because they're on the same trace on both sides, get connected to each other. Even though you can see this is the same big trace, but this side is an opening, they're still connected elsewhere on the board. So you're always going to have this. This is a normal reading. Shorted across these two is a normal reading. You want to read them diagonal. So if you have a shorted reading like this, you can go this way. Same thing. So every which way you can test it, other than like this, if you read a short, you got a problem with the critical safety cap. But this one's good. So there's only two components left. We got our voltage regulator, and there's two kinds. I'll actually talk about both of those here in a second, and our C38 width cap. The horizontal width cap here, C38, if that's shorted, they'll take the fuse out, as well as the voltage regulator will take the fuse out. So our C38 corresponds to these two pins here. Uh-oh. That is shorted. C38 is dead short. Look at that. Let's go to our ohm setting. Get out of here, ground wire. Holy cow, that's dead short. C38, so it's in circuits reading dead short. So the only real way to remove it from the circuit, the only real way to test it properly is to remove it from the circuit. So we'll turn on our soldering iron. And in the meantime, let's test our voltage regulator. Now, real quick, let me get some teaching aids here. Okay, let's see here. I've got a number of extra parts here. And as you can see, there are two different kinds of voltage regulator. Alright, let's talk about these. Okay, so you read them differently. You'll see that this chassis has this kind, the 3130 with the 5 legs. That's this one here. And let's zoom in a bit. Okay, now your 3130. There are 5 legs, but it only uses 4. The 5th leg has no connection. It's there, but in the chassis, the 5th pin is not connected. There's nothing hooked up to it. There's no trace. It doesn't get used. It's just 5 pins for security of the IC. So when you test this one, you go to your diode checker, and you're going to go to pins 3 and 4. There you go. Pin 3 with the negative, pin 4 with the positive on diode checker, and it's going to read, there's your diode. So that is a good voltage regulator, not shorted. However, on this kind, the 3123, it's pins 1 and 4. Pins 1 and 4 is how you test this one. So if your chassis has this kind of voltage regulator, it's 1 and 4. If we go to swap these around, am I lying to you? I shouldn't be. Should be 1 and 4. It may be a different reading, but it's pins 1 and 4. There it is. Okay. It doesn't read like a diode, but it's 0.987. There. Oh, I'm sorry. It's 1 and 2. That's kind of odd. I know the confusion lies because on a 7000 that uses this voltage regulator, the B plus wires go to 1 and 4. On this type, the B plus wires go to 3 and 4. So my confusion, I guess, lies in the fact that it goes to 1 and 4 on. Let's try this one. Don't make a liar out of me here. You can see this is a slightly different. I think this is a. You can see how different the labels are. I think maybe if I put some alcohol in here, this will come right off and it's a fake, but you can see how different it looks anyway. So if we go to 1 and 4 on this one, see that one reads it. Oh, I was touching this metal part on my table here. Gotta be careful when they do that. See, there you go. There's pins 1 and 4, 5.91. I think I got some fake chips. Look at that. Wow. Quite interesting. Huh, glad I didn't use these. I got 1, 2, 3. I got 3 of them. I got 3 of them. Wow. That's insane. Let's test another one here. 1 and 4. That's not right. 1 and 4. We already did this one. That's not right. 1 and 4. That's not right. Huh. Wow. I don't think these are the correct ones. I think these are mislabeled, or I got some counterfeit ones. Well, I'm glad I found that, because you see I go to this one, 1 and 4. That's correct. See, 0.590. I go back to this one. I go to 3 and 4. 0.560. Yeah, these are some bad. These aren't right. Wow. Well, hey, we found something out. That's good. All right, so back to what I was saying. If you got this one is 3 and 4, should read the diode. And on this one, 1 and 4 should be the diode. Yeah. So that's good. I don't know, these other chips, that's crazy. All right, so a little bit of information for you depending on which type of voltage regulator you have. And you'll notice that on this one, another way you can test the voltage regulator, we'll get to it in a minute, is off the B+ pot, or B+ resistor. But if you actually follow the traces and look at where the wires are going, the blue wire and the red wire, they're connected to pins 3 and 4 on the voltage regulator. Now if you have this kind of, well, I want to get the right one. If you have this kind, the wires are connected to pins 1 and 4. So depending on which voltage regulator you have, your wiring is going to be a bit different. But the easiest and quickest way to test your voltage regulator is just to go to your resistor here for your B+, and it should read 180. It should read about 175 usually. I think the 19-inch K7000 is 220, and the 25-inch here is 180. But let's see what this reads here. Okay. Shorted, just like the C38. So if this does not read 180 ohms, and you can see right there it's reading shorted, either the voltage regulator is shot or the width cap, the horizontal width cap C38 is shot. Come on, get a connection on there. There you go. So, yep, let's pull our C38 out of circuit here and see what it reads out of circuit, because if the voltage regulator is shorted, it could induce a shorted reading onto C38. So let's pull this out of circuit here, which is proving easier said than done. There we go. And let's get this side out. All right, so our C38 is out. Let's test our pads and make sure our pads aren't still shorted. Zoom out a bit. Okay. Our pads are here, this one and this one. And, well, they're not shorted anymore. Is it going to go up to infinity? Nope. Well, it's not shorted. If we test our cap, any bets on whether it's shorted or not? I'm betting that it is. Let's test, here we go. Shorted. So there you go. C38, horizontal width cap. shorted, blowing the fuse. So we'll set that aside, and we'll still go ahead and test our voltage regulator. And again, like I said, on this type it's pins 3 and 4. On the other type it's pins 1 and 4. And we'll zoom in. We should read a diode. And pin 1 is when you're looking at the chassis with your flyback on this side. Pin 1 is to the right. So we count over 1, 2, 3, and 4. Oh, our voltage regulator is shorted as well. Look at that. We can go to diode checker, but it's going to beep at me. Yeah, wow, look at that. So our voltage regulator is shorted, and our C38 is shorted. 2 components. That was the last one. The flyback, you know, if the flyback is bad, it's generally not going to blow your fuses. It's just not going to give you high voltage. I've never seen that I can recall a flyback that takes out fuses. So that's all the components you should test for fuses blowing. Of course, you want to look over the chassis and make sure there's no broken traces as well. But usually it's a failed component that's taking out the fuse. So we found it. Voltage regulator is bad and C38 is bad. So let's get to replacing them. Obviously I've got a whole bunch of these types, which I guess these 3 are all good. And these 3 are all bad. No, I have a 4th one of these. So I have 4 of, I guess, the good ones, the non-counterfeit ones. But these ones here with the odd, you can see how this is even coming off here. Yeah, I'm glad I found this, because these 3 are definitely not correct. So I actually kind of interested to put them in and see what happens, but not on this chassis. This is somebody else's. Yeah, these ones here are look much more correct. So I have no idea where I got these. I've had these for so long, I'm probably going to just trash them. But you saw before how you should correctly read them on pins 1 and 4. It should read like a diode. So I've actually got 2 of these like this one. So I'll put this brand new one in here. And I'll grab a C38 from a spare chassis. And we'll see what happens. I don't have any of the spare chassis up here at the moment, so I'm going to cut away and go get one and come back, and then we'll do all the repairs and put it on a tube and see what happens. So one moment. Alright, so we got a new voltage regulator, and I got my new C38, which I robbed from a parts old Zenith K7000 that had the flyback went out, and of course they're unobtainium, so this became a parts chassis. So I stole the C38 from this chassis, which is right here. And you can see here when I test it, it's going to read not shorted. This reading is insignificant because it's going through my body, but it's not shorted. That's all I'm interested in. And you can look at the reading, and it says, I don't know if you can make it out, it says 474, 200 volts. This one is 0.39, 200 volts, so it's close enough. Which this would be 0.74 versus 0.39 basically. So close enough, shouldn't affect it that hard. We can always compensate with the coil. So then again we take this one, and voltage or electricity always takes path of least resistance. So with the shorted component, even though I'm touching it with my fingers, it shouldn't make a difference. Still should be 0. Yeah, 1 ohm, 0.6. So definitely bad. Cause number A. And cause number B, of course, was our voltage regulator. Let's test it one last time just to make sure it's good. Oh, gosh darn it. That's good. 3 and 4. So now let's take our bad one out, and we'll test it out of circuit just to make sure it's actually faulty, because you could have something else making it read bad. So let's unscrew it here. Nut. Screw. Let's turn on my desoldering gun here. And while that's going on, I'll go ahead and just wick away the 2 pads for C38 and get C38 installed. There we go. Just easier that way. Alright, let's see if I can get this to line up somewhat easily. This is not going to be fun or easy. I'm going to have to bend my leg here. That should be good. That should be alright. Okay, now, it doesn't matter which way you put these poly caps in, but you always want to put them in the same way they came out, which for me the writing is facing towards the flyback. So let's get this in there. It doesn't like me, nothing ever does, because I can't see. Alright, there we go. C38 is in. Let's solder it in place. You bastard! I'm so stupid. I should have just tacked it in on both sides. Okay. Don't do that to me again. Sorry about that. Okay. Alright. And let's just tack this in here. There we go. Now you won't go anywhere, you rat bastard. Alright, that looks pretty good. And that looks pretty good. Good solid joints, nice and shiny. Okay, in the meantime, let's give it a look over here. That's not a look over, that's the opposite. Okay. It looks very clean. I don't see any pins touching anywhere. Nothing horribly burned. For some reason the centering pin, I'm going to take this out and put it back on center, because I've never seen a 7000 be on any position other than center. So I'll fix that real quick. But everything else looks pretty good. Nothing that should need a decent reflow. So yeah, I'm going to do some reflowing, I guess, and some other stuff off camera, because this is just basically for testing of the fuse blowing. But I do see some stuff, but nothing too bad. Normally you'd want to inspect this, you know, because you've got, in this area that gets hot, you've got lifted pads for your resistors, lifted pads for other stuff. This area here can get very hot and cause all the oxidation on the solder, so you'd want to remove the old solder, put new solder on, things like that. So you want to give it a good inspection as well while you're doing your work. You know, your yoke header pins, you want to reflow. You want to reflow anything in the hot area that's oxidized, things like that. So I'll do that, especially I think this ceramic resistor here was at R89. Those two pads can get very hot and burn up and stuff, so give it a good look over while you're doing your work. But this seems to be pretty good actually, so I'll do everything else later off camera, because I want to get back on topic here. But okay, so we've got our C38 replaced. Let's check to make sure that it's still not shorted in circuit. Well, it might be because of the voltage regulator. It's, well, let's see, let's go back to ohms here. And it's not. Okay, so it's definitely shorted outside of the shorted voltage regulator. So I guess this is a lesson for all of us. If your C38 reads shorted in circuit, it's definitely bad and does not. It's not very. It's not indicative of also having a failed voltage regulator. So you can have a failed C38 only and still have a good voltage regulator, and we just proved that by changing this out. And even with the shorted regulator in there still, the pads aren't shorted anymore. So you can have an independently shorted C38 blowing your fuse. So I've actually had that in the past where it was just C38. So now I guess all that's left is to replace the voltage regulator and hook it up and fire it up, see what we get. Oh, I just noticed that the ground wire is broken. The DAG wire, this is the DAG wire that goes to the neck board. And it looks like it's broken off of the neck board. So I'll have to fix that. Not uncommon with working on a chassis where it's back and forth flopping the neck board around. That's why I mentioned on my U5000 video, I always like to disconnect the ancillary stuff so it doesn't get broken off, but on a 7000 you really can't without doing a bunch of extra work. So I'm gonna have to get this soldered back on. I'll do that after this here. This already has all the caps replaced and a new flyback. This was done a long time ago, so I don't think that's any of the issue. I think it's just this voltage regulator and C38. So let's get the voltage regulator out of here, and let's zoom in so you can watch this fun action. All right. So you put this on here and let it flow the solder, and then wiggle it around, and there you go. If you don't have one of these, get you one of these. They're a lifesaver. Alright, now let's zoom back out. Oh, I always go the wrong way, sorry about that. Okay, I'm going to clean this out here since we just used it for a lot of solder. And I always do that before I put it away because you'll end up with that solder will have gone into a particular somewhere in the horn here, if you will, and it will harden when you turn off the gun, and you'll never get it to heat up enough for it to work again. So, word of advice, I always clean it after I get done using it. So that should come out now rather easily. There it is. This looks like someone's replaced it in the past with this gold thermal paste. Yeah, this is a bit overkill because it doesn't get that hot. So let's go ahead and test it here. Let me get something to put this on because it's covered in compound. So let's test pins 3 and 4 again out of circuit. Alright, diode checker, pin 3 with negative, pin 4 shorted. That's a goner. In the garbage it goes. And one more time we'll test our good one. Pin 3, pin 4, good. So let's get this puppy in here. Let's make sure all of our feet are lined up. Yep, that should be good. You'll notice here pin 5 has no pad, or there's pad, but there's no trace. It's nothing on the top side, nothing on the bottom side. Pin 5 is just an added pin for security of the chip. It's only 1, 2, 3, and 4. All right, so let's get this back in there. Alright, and good lord. Oh, that's my work phone, sorry. I'm supposed to be working while I'm doing this. So give me a minute here, sorry. And we're back, sorry about that. I don't like to do jump cuts or cutaways because if I don't have to. I could have cut that phone ring out, but I don't like to do that for the sake of continuity, so you realize there's no funny business going on. So it should be, I don't know if it's going to be in zoom. My camera shut off while I was on the phone, so I don't know if it'll be zoomed out or in from where it was just a moment ago, but I haven't touched it. So no funny business going on. I still got the voltage regulator sitting here. I'd like to take some of this thermal paste off, but because it's getting everywhere. But that's okay. I guess I'll just use my tweezers here. I'll put this back in place if I can. All right. Let's get our screw in here, and I talked about having a circuit breaker in place of the fuse, but I forgot that it's actually in my tool bag up at the arcade, so I can't do anything with it. So I'll just put another, I got the fuse here from this donor board. We'll just put this in there. I'm sure it'll be fine. Well, it fell down on the floor, and I lost the damn thing. Give me a moment. I'm old. Well, wouldn't you know it? Like anything else I drop, it disappeared off the face of the earth. Well, I'll have to come up with some other option here. I'll tell you what, hang on, let me cut away and I'll dig through all this junk. I got a stack of bad chassis here on the ground, so give me a moment here, sorry. Alright, I found it. There it is. Sorry about that. Okay, so let's test this one. Good. Snap it in. Alright. Now we got that out of the way. Let's solder in our new voltage regulator. There we go. Alright, there's one. 2, or actually 5, 4. 3, and 2. 5 glorious solder joints. Alright. Alright, here we go. Oh, I gotta fix that ground wire, but let's test our regulator again. Again, pin 1 is closest to the flyback, so 1, 2, 3, and 4. Well, it's reading 0.157. What does my resistor read? Oh, there we go, 180 ohms. And look at what it says, 180 ohms. So we are golden now. Let me fix that ground wire. We'll fire it up, and I'm 100% positive that it will work just fine. Okay. Where is that puppy? Here it is. Alright, let's... Again, my tool bag is at the arcade, so I don't have any strippers here, so... We'll do it the old-fashioned way. Let's get a little flux on this bad boy. That's a lot. There we go. The perfect amount. As Tronics Fix would say. Well, he refers to it on the solder, on the paste, but I'll talk about it on the solder. There we go. Let's get a rag and wipe off the residue. And let's solder this back on to here. Can I make this easy? Probably not. I don't know. Let's just do this. There we go. All right. Time to get the picture tube up here and see what happens. Get our meter put away, all of our ancillary tools. All right. So before I hook it up to the tube, I'm going to do all my reflow and inspection on solder pads and stuff. Then we'll cut them back and I'll have it hooked up and we'll. Whoop, that was the bad fuse. All right, let's review actually real quick. We had a bad fuse, we had a bad C38 width cap, and we had a bad voltage regulator. So I'm going to do all my reflow and inspection. We'll get it hooked up to the tube. When I come back, we'll fire it up and see what happens. Okay, here we go. I got everything hooked up. This is a U5000 tube and frame, so I don't have proper isolators and stuff for the 7000. So right now it's just sitting on an envelope, but the envelope is good enough to isolate it from the frame. So we've got our anode connected, count to 5, anode, neck board's hooked up, our yoke's hooked up, which I don't know if you can see, it's connected right there in front of the coil. That's 3, and we got our DAG ground is shoved in there, and our video 5, 1, 2, 3, 4, 5. So we are ready. I have not turned it on yet. I hope it. I'm confident actually that it will work. I will not adjust colors. I will not adjust position, screen size, everything, because it's all set up for the tube that this originally came from. And I don't want the owner to have to go through all that headache. So the whole point of this is just to make sure it fires up and gives me a picture. If it's upside down or backwards, I might flip the yoke connector so you can see what to do if you ever have that problem. But okay, here we go. We got power hooked up right there. And fingers crossed. Let's keep an eye on it. Here we go. Well, I'll be dipped. Oh, let's see what we get here. Hot diggity. Well, it's upside down. Not a big deal. Let's turn it off. And the way to fix that is, this is going to be difficult. The yoke connectors, you can have one of two ways. You need to flip it around. The vertical is the green and the yellow. I don't think I'll be able to do this on the camera here, but you can see the green is on the outside, yellow is inboard. So let me put you down here real quick, and I will flip the green and the yellow around. Requires 2 hands, and I apologize, just to make it easier this way. All right, and now, all right, we're re-secure, re-isolated, and now you can see the yellow is inboard and not outboard. Where'd you go? There you go. I'm sorry, the yellow is outboard, green's inboard. So I flipped it around. Originally it was green outboard, now it's yellow outboard. So you can see that it's broken in half and it's now flipped around the opposite way. So that's how you take care of an image that's upside down or backwards. You just flip your yoke connector. The yellow and green is vertical and the red and blue is horizontal. Alright, sorry about that bad camera work. But now let's see what happens. Outstanding. Let's actually get this on the tripod here. There it is. Outstanding. So bad C38 width cap and bad voltage regulator. Yep. There you go. It's got some kind of interference, it looks like. No, it's gone. Okay. Yeah, like I say, I'm not going to adjust colors or position or size or screen or nothing because it doesn't belong on this tube. But yeah, there it is. Success. You got a blown or a blowing fuse. Whoa. Well, that was very interesting. Very interesting. The entire room here filled up with smoke. The flyback decided to let out all of its magic contents, and it was all due to the insulator for the HOT was not insulating. As soon as, well, basically I replaced the flyback. The flyback let the smoke out, and you can smell it. Here, smell it. Smell it? It's bad. So it's toast. When that happened, of course, obviously I had to replace it, so I put a brand new one in. I'll show you in a minute. After I did that and powered it up, there was arcing and sparking coming from the side of the HOT. So it turns out the insulator is bad. So I stole another insulator from another chassis, and just for the sake of longevity and peace of mind, I put a new HOT. This one still reads good, but I don't trust it. So the insulator was bad, allowing the voltage to leak through and onto ground. I think that's what took out the flyback. So after putting a new flyback in it and replacing the HOT and the insulator, now it works. So let's fire it up. Back to life. Oh, there you go. So, yeah, I should have, when I first turned this on, I mentioned how it had some kind of waviness or ripples or some interference. I should have taken that to heart because now I don't. But what happened, yeah, it's got a brand new flyback and a new HOT and a new HOT insulator. So I don't know if the HOT insulator being bad caused the cascade failure of the width cap and the voltage regulator, or really what happened, but that's what happened on this instance here. After repairing it, it lasted for about 15 seconds and poof, flyback let its magic smoke out because of the bad insulator on the HOT. And the only reason I found that was because, like I say, I changed the flyback out, and after powering it back on, I had some arcing coming from the right-hand side of the HOT, and that's how I found the bad insulator. But I don't trust that HOT, so I went ahead and changed it anyway. So after a new flyback, a new HOT insulator, new C38, and new voltage regulator, it's good. So I'll let it run for a good couple hours just to burn it in, make sure. But obviously, if there's no second, I don't cut away here and come back showing something else wrong, just assume that it worked fine. So I don't know what happened initially, but I think that HOT insulator caused this entire cascade failure. So anyway, there it is. Now it's fixed. That was quite exciting there. And otherwise, I hope this helped you out. Kind of excitement there at the end. I didn't expect that to happen. I expected this to be a basic video of how to troubleshoot the blowing fuse, but turned out to be exciting. So thanks for watching. Hope you learned something. Hope it helps you out. And subscribe to the channel if you haven't. And I appreciate it. And we'll see you next time.